Today we're going to talk about, this whole chapter is about right triangles, a whole entire chapter just on right triangles. Can you imagine that there's that much information just about a right triangle? You already know something about a right triangle, don't you? Let's make that. So, I mean, it's right in the name, isn't it? On a right triangle, what kind of special angle is in a right triangle? How about a right angle? Yeah, it's 90 degrees. Okay, it's a right angle and it's 90 degrees. So let's just talk about the right triangle just for a second, then we'll talk more about what we're going to do in this lesson. Um, what about this side? This side right here has a name, doesn't it? It's the hypotenuse. And you know it's the hypotenuse because it's opposite the right angle. People say, well, it's the hypotenuse because it's the longest side. Well, let me just show you that that's not always true, because watch. What if I did this right here? This right here is the longest side, isn't it? I'll put longest. That right there is the longest side. Is that the hypotenuse, though? No, you can't have a hypotenuse unless you have a what? A right angle. Okay, so this is not the hypotenuse. So some people say, well, it's the hypotenuse because it's the longest side. That's not necessarily true. Now, the hypotenuse is always the longest side of a right triangle. Okay, so don't get that confused, though. But on a right triangle, the hypotenuse will always be the longest side. Everybody got that? Okay, so let's just write that word down. Hypotenuse. I think I looked that up one day on why they call it hypotenuse, and it's been a while, and I just completely forget. I don't know if it was like from a Latin word or something like that. Maybe that's we're not going to look it up now. But anyway, that's called the hypotenuse for whatever reason. When I was in college, we get our portraits taken, and the photographer would always ask you what your major was. And I don't know what the joke was for the other majors, but I said, I'm a math major. And he's like, okay, ready, say hypotenuse. And every year, 4 years I was there, and every year he would tell me, say hypotenuse every single time. I don't know if that's supposed to make you smile or what. Maybe that's why I look so dumb in my pictures, because my mouth is all weird, because I was saying hypotenuse. But I just thought that was kind of funny. So I don't know what an English major had to say. Maybe like preposition or something like that. I don't know. I have no idea. But for the math majors, he always made us say hypotenuse. Anyway, there you go. That's the hypotenuse. What are these two sides right here? The non-hypotenuse. They would be called the legs, or leg, right? And that's a leg of the right triangle. So we need to be able to describe the sides and the hypotenuse and all that good stuff, all right? And it's a right triangle because it's a right angle. What about these angles right there? What kind of angles are these angles going to be? They're going to be acute every single time. You cannot draw a right triangle with one right angle and an obtuse angle. You can't have a right triangle with an obtuse and a right. Why is that? I could sit here all day and I couldn't draw a triangle with a right angle and an obtuse angle. Because it wouldn't be a triangle. Why not? Give me a... That's right. The angles would be what? Compared to 180, they would be more than 180, right? If I had a 90 and an obtuse, remember an obtuse is bigger than 90, so that's two angles right there that have to be bigger than 180, right? And there's no way I could have a triangle out of that if two of the angles equals 180, because all three have to equal 180. Make sense? I'm just brainstorming about right triangles right here, okay? We'll talk some more about this later. I'm just trying to get you thinking about right triangles before we do this lesson. Now, what's always true about these two acute angles? Now, we said both of them are going to be acute every single time. Every time you have, I can't spell right. Let's try that again. Every time you have a right triangle, these other two angles will always be acute angles, less than 90 degrees. What else do you think? A little more specific, what might be true about those two acute angles? Remember, this is already 90 degrees. Are they always going to equal 45? They could. There's a situation where they could equal 45, so that's not exactly wrong. But what's always going to be true about these two acute angles? That's right. When they add up to 90 degrees. All right, so we could say, we had a word for that, didn't we? I think we did. Did we talk about that word? I know we talked about supplementary, didn't we? Remember two angles that add up to 180 degrees? Complementary. Did we use that word? Yeah, I thought we did. Yeah. So these two angles right here, these two acute angles will always be complementary. So I don't know how I'm going to do this. I'll just kind of, we'll say they're always going to be, we'll put a little arrow here and here. These two acute angles will always be complementary. And what is that? Does that just mean they say nice things about each other? They compliment each other? No. All right, it's a different spelling anyway. So complementary means they add up to 90 degrees. So the acute angles of a right triangle will always add up to 90 degrees. Everybody with me now? Okay. So again, that's I don't even know it's all in this lesson or what, but there are just things off the top of my head that I knew about right angles or right triangles that I thought we'd talk about. Now, what we're going to do today is we're going to talk about a specific situation. Okay, it doesn't happen all the time, but every once in a while it happens, and we're going to learn some things about it. So I'm going to start off with a right triangle, and a lot of times they draw it like this. And I'm trying to make that angle up at the top a right angle. Let's stretch this out a little bit more. Does that kind of look like a right angle up here? It's pretty close. All right. So there's a right triangle. Just kind of have it sitting on its hypotenuse, right? Everybody see that? So there's a right triangle. Nothing super special about that, but here's what the deal is. If I take a line segment from this vertex or from this right angle, and if I drop it straight down, we actually have a name for that. I think we've talked about that word before. What is it when I go perpendicular to the opposite side? Do you remember? It's called an altitude. Remember that? Yeah? Yeah, I think so. Because here's the ground, right? Here's a little airplane. Remember me drawing this stupid airplane? Remember that? You never seen my stupid airplane? There it is. I don't know. It's pretty cool looking. What does it look like? A flying penguin? Yeah, I guess so. Put little eyes and anyway, that's my airplane. That's about as good as it gets for my drawing abilities. All right. You ever get in an airplane and there's a pilot on there and you get in the cruising altitude and he's like, welcome to Hamrick Airways. This is your pilot speaking. And he always talks like that, doesn't he? Doesn't the pilot always talk like that? Yeah, this is your pilot speaking. He tries to talk all cool and stuff. Anyway, but what do they usually tell you? They tell you some stuff. They tell you what the weather is going to be, where you're going to land. They tell you like how long it's going to take to get there and all that kind of stuff. But they also tell you when you get up to a cruising speed, what do they tell you? They tell you your what? Your altitude, right. They tell you your altitude. And your altitude is what? It's not the distance from the plane to like where you're going. It's not the distance from where you left. It's what? It's the straight up and down distance, or the what in geometry? Give me a good word. If it's a right angle, it's what? Starts with a P. Perpendicular, right. It's the perpendicular distance, okay? That right there is the altitude. Altitude. And you've heard that word before, right? Usually planes fly, I don't know, 20,000, 30,000 feet, something like that. And they say, our cruising altitude is going to be 27,000 feet. Enjoy your ride, or whatever. Whatever they say, okay? So that's altitude. So remember the altitude. So what is this? This goes from a vertex, and it goes perpendicular to the opposite side. So what do I call that little line segment right there? That's my altitude. Everybody got that? So think of the plane being right here, and this is the ground. This is the straight up and down distance, or the perpendicular distance, and we call that thing the altitude. All right? That's pretty important. Oh, you know what? I skipped something. Skipped ahead. I got to do something. Put that on hold right now. All right? I'm going to copy that and get rid of it. All right. Now, it's still the same section, but I got to talk about something right here. Let's talk about this word. And I'm not really going to give you really any explanation. I'm just going to show you how to do it. And that's probably all you care about. It's called the geometric mean. Do you remember the word mean in math? It doesn't mean that they say bad things about you. That's not what it means. It means what? It means the average, right? So this is a geometric average. Now, don't think of it as an average, adding two numbers and dividing by 2. It's really not what we're doing. This is a different type of an average. I hate to even use the word average here, but you've seen that word before, though, haven't you? And this is what a geometric mean is. What it is, it's a proportion. We just finished doing a chapter with a bunch of proportions, right? So it's a proportion, which means a fraction equals another fraction. Everybody see that? The geometric mean is a number. Let's do this in a different color. Let's do it in red. The geometric mean, watch, would go right here and right here. That's a variable. That's what the geometric mean is. So here's the question. They're going to say find the geometric mean between two numbers. All right, and let's put the two numbers in here. Let's say 4 and 9. So it says, what is the geometric mean between 4 and 9? So what do you do? Here's the question. Find the geometric mean between 4 and 9. You set up a proportion, okay? Set up two ratios. Everybody see that? And your geometric mean is the x. It's in red right there. So I put 1x on top, not just on the bottom, but opposite the other one. You see that? See how it's diagonal? Don't put 1x on top and 1x down here on the bottom. Put them diagonal. Now, could they go in this spot right here? Yeah, they could. All right, you could put the x here and here. But for some reason, I always put the x on the top left and the bottom right. So when it says, find the geometric mean, I'm putting the x on the top left and the bottom right. It's the same variables, not two different answers, is it? But the variable shows up in two different places, though. So how would you solve for this? If I set it up, if it said, find the geometric mean between 4 and 9, that's the question. This is what I would set up. Everybody with me on that? Anybody writing this down? I got like 2 people writing. So x is a geometric mean between 4 and 9. So what do? We just did a whole entire chapter on this stuff. What do we do to solve for x here? Cross multiply, exactly. So we cross multiply. Now watch. What's x times x? Is it 2x? It's x squared, right? X times x. If it was x plus x, it would be 2x, okay? But x times x is x squared. And that's going to equal, what do you think? 36, 9 times 4. Now, I'll tell you what, I'm just going to write the 9 times 4 in there just to show you where we get that 36 from, okay? And now, what do? You multiply 9 times 4, which is 36. And then, Lonnie, you said what? Square root both sides, okay? So, you square root this, you square root this. What's the square root of 36? It's 6. Now, is that the real average between 9 and 4 and 9 and 4? No. Okay, it's a geometric average, okay? But don't worry about what that really means. Just know how to find it. That's all I care about right now, okay? Just know how to find it. You with me? Now, sometimes they're going to give you... Now, I picked 4 and 9 because it came out nice and perfect. They're not always going to come out nice and perfect, all right? What if you get something that doesn't become a perfect square like this? Well, you're going to have to write it as a square root, right? So, for instance, what if I said, find the geometric mean between 3 and 7. All right. So how would we set this thing up? Set up a proportion, right? This is how I do it. Now, you don't have to do it exactly like this, but I kind of like to do it like this. I set up a proportion, and I got to solve for the geometric mean. Where is the geometric mean going to go? Yep, one on top, one on the bottom, right here. Diagonal to each other, okay? So that's my geometric mean. That's what I'm solving for. Now, it says between 3 and 7. So where do I put that 3 and the 7? Well, there's only 2 other places to put it, right? Now, does it matter that I put the 3 here and the 7 here? Could I put the 7 here and the 3 here? Yeah, why? I mean, why is it no different? Yeah, because you're just going to multiply them anyway, right? So it doesn't matter what order you multiply them in. Could I have put the x down here on the bottom here and on the top here? Sure. All right, it doesn't make any difference. Watch, I'll just show you. Actually, I could have put the x here and here if I wanted to. And I could have put the 3 here and the 7 here if I wanted. Look what's going to happen. When I cross multiply, don't I get the same exact thing? Yeah, so it doesn't really matter. I don't know. I just kind of like to put the x on the top left and bottom right. It's just, you kind of get into a habit. So let's do that. What do we get? X squared equals what? 7 times 3, which is 21. You're going to get the same thing here, aren't you? So it doesn't really matter how you set it up. But now what do we have to do? Square root and square root this, and x equals, can you do anything with the square root of 21? No, it doesn't come out even, does it? Alright, so I just keep it the square root of 21. Don't even write it as a decimal. I do not, everybody listen to me, write this in your notes, all you people taking notes, all 3 of you. Write this in your notes that I want you to leave it as a square root. I don't want you to write it as a decimal. Do not write it as a decimal. This is minute 1425, okay? Go back to the video, and I said at around 1420 or 25, I said, do not write these as a decimal. Everybody got that? I want it as a square root. Okay, now, I will, because I told you. Because I told you not to do it, okay? So you got to follow instructions. So you will not get it right if you write that as a decimal. I mean, that's fair, right? I told you about it. All right, and to tell you the truth, it's easier. It's even easier, isn't it? Writing it as a square root, because I don't have to pull the calculator out and I don't got to punch anything in. I'm already done. No, it's not technically the same answer because this is an exact answer. If you put this into a calculator, I almost hate to do this because you're going to say, you're going to remember that I actually put this into a calculator even though I told you not to do it, okay? But watch, if I take the square root of 21, I get this. Is that the same as this? Is 4.5 the same as square root of 21? It's not. That's a rounded answer. No, it's not. It's a rounded answer. It's an approximation. This right here is exact. This is exact. All right, you're laughing at me, but I should be laughing at you. Okay, I'm not going to, but it doesn't matter because it's just rounding it. This is a rounded number. Even if I took it out this many decimal places, that's still not the exact answer to this. Okay, it will, but it's not technically. You can debate me all you want, but if you write it as a decimal, I'm marking it wrong, okay? And you can complain and whine all you'd like. I'm telling you, I want it like this, okay? Because they're rounding it, okay? They're taking a rounded number, they're squaring it, and they still get this because they're rounding it to 21, all right? So that's why you're going to get the same answer. So you didn't really prove anything to me. You just took a rounded answer. Now, you may not think that's very important, but I'm telling you, if you take some upper level classes and things like that, they're going to want you to keep things as a square root. Not all the time. Sometimes it's okay. Sometimes it's perfectly fine to write it as a decimal. But for these answers, for this type of problem, I want you to keep it as a square root. I'm actually making things easier for you because you don't have to pull the calculator out. You might miss a button on the calculator. You might mess it up, or you might misread it from the calculator. That's happened to everybody, I'm sure. It's happened to me. So just keep it the square root of 21 and you're good to go. What if it came out to the square root of 36, though? Do I want you to leave it the square root of 36? No. Okay, if it comes out to a nice, perfect, even answer, this is not an approximation. This is a simplified, exact answer. All right, so I want you to write it like this if it came out to the square root of 36. Yes, because I just told you at minute 17:17 or somewhere around there, okay, I told you if it comes out to a perfect square, I want you to simplify it and write it like this. Okay, does that mean that they're different answers? Of course not. But it's a matter of following instructions. I told you I want you to simplify it to this. So if you don't follow the instructions, then you get it wrong. That's what life's all about. You got to learn how to deal with it. Whether or not you agree with it or not, follow instructions. Okay, that's a great thing to learn in life. Okay, now we know how to do that. We know how to find the geometric mean. Let's go back to that triangle that we had drawn before. Okay. What we're going to do is we're going to actually use geometric mean to find some missing parts of this triangle. And we're like, what in the world? How are we going to do that? Well, I'll show you. Let's label some of these sides. Label that A. We'll label this B. We'll label this C. We'll call this D. We'll call this E. And I'll tell you what. We'll call this whole thing right here, we'll just call it F. Is that all right? So we don't have to put D plus E to add them up. We'll call that F. So I've labeled everything. Okay. Now there's three things, three different proportions that we're going to do. Three of them. All right. The first one is to find the C, or the altitude. All right. So to find C. Remember, we're going to do three different things. This is the first one. I'll put a 1 here. That's the first one we're going to do. In order to find C, this is what they tell you. Now, I'm not really caring that you know why we set it up. I could explain it to you, but you probably wouldn't care. All right? All you want to know is how to do this thing. So I'm going to show you how to do this thing. So what the theorem says is C, this altitude right here, is a geometric mean. Okay, so C is a geometric mean. Let's stop right there. What is that? How are you going to set this thing up then? If C is a geometric mean, the altitude is a geometric mean. I set it up as a proportion, right? And where do I put the C this time? I'm not solving for X, I'm solving for C. It goes here and here, right? That's where the C goes. Tell you what, let's oops. let's make this red so it's the same color as on the triangle. Stay color coordinated. Daniel, I thought you got tired of that by now. Okay, that's why I haven't said anything. I just figured you'd lose interest. So now I got to say something. Okay. Thank you. Yeah, that's hilarious. So many things I could say that would be mean, but I'm not going. I'm not going to. I'll keep it all in. Turned over a new leaf, right? I'm the new Mr. Hamrick now. All right, hush. Sure you were. All right, so C is the geometric mean. Now, between two numbers. Which two numbers? Well, the altitude is a geometric mean between. Now, I'm going to say this kind of quick, but we'll go back and look at it. The altitude is a geometric mean between the two segments of the hypotenuse. Hear what I said? So what are the two segments of this big hypotenuse? D and E, that's right. So C is the geometric mean between what? Between D and E. Now, you know what they're going to do here. They're going to put numbers in here, right? They're going to put a number in for D and for E. And so in order to solve for C, you put it here, you cross multiply, you get C by itself. And you can actually find the length of this altitude just knowing those two segments, right? Pretty easy? Okay. So that's how to find C. Now what we're going to do, yeah. Well, they're going to be actual numbers, like a 3 and a 7. Like if this was 3 and this was 7, we'll put a 3 and a 7 here, cross multiply. So it would be square root of 21. So C would be the square root of 21 if this was 3 and if this was 7. Okay, does that make sense? In fact, let's just put those numbers in. Nah, let's not do that. Let's use the letters, and then we'll put numbers in after we do this, okay? All right, so now, that was the first one. How many different things am I going to do here like this? 3 of them. So that's the first one. This is the second one. And we're going to find, to find A. So, I don't know. All right, look at it. We're going to find A this time. So we're going to set up, again, A is a geometric mean. So A is a geometric mean, C is a geometric mean so far. And then the third one, I'll give you a hint, is going to be B. All right? All right, so we're going to learn how to find A, B, and C. All right? And you just have, they're just different proportions. You got to know how to set up the different proportions. So let's do this. So A is a geometric mean. So what I do is I set up my little proportion, and where do I put the A? If A is the geometric mean, I put it here, and I put it here. All right? Now, what is it between? A is a geometric mean between, it's not between D and E, because that would be the same thing as C. Now watch this. A is the geometric mean between the whole entire hypotenuse, which is what? F. And listen to this. The segment of the hypotenuse that's adjacent or closest to A. Hear what I just said? So A is a geometric mean between the whole hypotenuse. What's the whole hypotenuse? F. And the segment of the hypotenuse that's adjacent to side A. D. Very good. See how it's next to it? It attaches to A. You got two segments of the hypotenuse, don't you? You got D and E. Which one's closer to A? Is it D or is it E? It's D, isn't it? Okay? So A is a geometric mean between the whole thing, the whole entire hypotenuse, which is F, and the one that's closest to the side we're looking for, okay? Which is what? D. Should have put that in a different color. Let's put that in yellow, just to stay coordinated here. All right? So the stuff in red are your geometric means. Now these are going to be numbers. All right? And we'll put some numbers in just in a second after we do this third one. All right? So now let's do the third one. And put a 3 up here. Now, what do you think we're going to find now? I told you a little bit ago what we're going to find. We're going to find what? We're going to find B this time. Now, B is very, very, very close to A. It's kind of the same thing. It's just different. All right? Same thing, but different. Don't you love it when people say that? Well, if it's the same thing, then it's not different, is it? You'll see what I'm talking about. Right, that's what I just explained. All right. So here you go. Look at this. Let's get rid of this circle right here. Now what we're going to do is we're going to solve for B. We're going to solve for B. It's very, very close to what A was. So what do you think? B is the geometric mean, so where's the B going to go? It's going to go here. It's going to go here. Now, it's the geometric mean between what and what? What do you think? Take a guess. Between the whole thing, good, F, and which one? E, right. The side, the segment of the hypotenuse that's closest to this side. You see that? So A and B are really close. Look, A is a geometric mean between the whole thing and the little segment that's closest to A. Well, B is the geometric mean between the whole thing and what? The segment that's closest to the B. And that would have been E. Everybody see that? And that's how you do it. Oh, goodness, I forgot. I wonder if I hit shift. No, yeah, it does. What? Let's see if I can do them both at the same time. Look at that. See? Just learning every day. All right, let's do this. Now, we got all these letters in here and stuff, but let's make these some numbers. All right? And we'll put some real numbers in here. We did 3 and 7 before. Let's do another one. Let's say this is 5 and this is, let's just say it's like 12 or something like that. Okay? Of course. Let's take a look at this. Now, I'll keep this up here just so you have that to look at. And you can look in your notes when you do this, right? All 3 of you that are taking notes. All right, so let's do this in a different color since we're doing real numbers this time. Look at this. Let's solve for C. Let's find C. So C is a geometric mean. So this is what I do. I set up my little proportion. I put C here and here. It's between what and what? 5 and 12. That's right, between 5 and 12. All right, and then how do you solve for C? Cross multiply. So C squared equals 5 times 12, which is what? 60, right? So C would equal what? Can you do that part in your head? Square root of 60, right? Because you took the square root of both sides, right? Square root of this, square root of that. That's 60. It's a square root of 60. Now, you can simplify the square root of 60. I'm not going to make you do that in here, all right? Just keep it the square root of 60. I'm perfectly fine with you just keeping it like that, all right? There are some geometry teachers that would make you simplify this, but I'm just concerned. No, you can't put it in a calculator because, remember, we talked about that. We had a big, long discussion about that. I don't want an approximation. I want an exact number. This is an exact number right here. You don't. You leave it like that. That's your answer, okay? You guys want to make this harder. I'm trying to make it easier for you. You guys are fighting against me, okay? I'm trying to make this easy. I'm trying to make it easy. I really am. Don't put it into a calculator. Just keep it like that. C is the square root of 60. Now, if it really, really bothers you, listen, if it really, really bothers you what the square root of 60 is, let's put it in there. Now, don't write this as an answer because I'm going to mark it wrong. All right? The square root of 60 is about 7.7. All right? And make sure, listen, make sure that kind of makes sense. Does that make sense for that to be 7 if this is 5 and this is 12? Yeah, it looks pretty close. If it was like 92.3, that would look really crazy. Okay, so you know you did something wrong, right? So make sure that you understand that. All right? Let's find A and B now. So how do I find A? A is the geometric mean. So watch. A is the geometric mean between what? Between the whole thing. What's the whole thing, though? It's 17, right? So you had to figure that out yourself. I didn't put it in there. Okay, it's not that hard. 5 and 12, right? So it's between 17 and what? 5. Why'd you do 5? That's the one that's closest to the A. All right? Now watch. It's going to look a little ugly, and you're not going to really like what these answers look like, but this is perfectly fine. So you cross multiply, so it's A squared equals whatever 17 times 5 is. I have no idea what that is. What is 17 times 5? 85? That sounds right. Okay, so 85. Now, what do we do? Square root. Don't forget to do that. Don't just write 85, because if you write 85, that's wrong. The square root of 85 is a lot different of an answer than 85. So, right, well, 85 is an exact answer, but it's not the correct exact answer, right? So that's what it is right there. Again, let's just see if it kind of makes sense. Square root of 85. Oops. Why do you get frustrated?
Because I don't know if it's going to come out.
It's around 9.2.
So
you don't have to know. I'm just doing that as a little check. Does that look like it would be right? Absolutely. All right. Yeah, that's how I feel when I'm trying to teach you, to tell you the truth. All right, here we go. Let's solve for B. Let's look up here again. Let's solve for B, because you probably won't have all these things written down in front of you when you take a quiz or a test. That'd be a waste of time. They're just there to guide you at first, but you should be able to do this without looking at these things right here. So if you find B, B is a geometric mean between what? The whole thing and the side that's next to B, 17 and 12. That's all it is. Okay? So B is a geometric mean. Kind of. They could be twisted maybe a little bit, but you're always going to have one big right triangle and then an altitude drawn to the hypotenuse. Okay, that's the only time when this stuff works. All right, so it's kind of limited on the usefulness of this, but it does work. Well, I'm right now I'm doing this about as easy as they're going to make it. All right, they're going to actually do some other things, and we'll talk about that in a minute. Okay, so look, I'm just trying to get you understanding the relationship between these three things. All right, so B is a geometric mean between the whole thing, 17 and what, 12, and then you cross multiply. So watch, B squared and 17 times 12. Is that what it was? 17 times 12. That's 204, and just leave it. Okay, that's 204. And take the square root, so B is what? The square root of 204. You don't even have to put it into a calculator after this. Just keep it like this, this, and this, and I'd be perfectly fine. That's how I want you to do it. This is how I want you to write your answers, just like this. Make sense? What do you think? Yeah. All right. We got a few minutes here, so let's really yeah. After I teach this lesson. Look at this. Now, this may not look like it's the same thing, but it really is. It's just changed up a little bit. This time it's not sitting on its hypotenuse, is it? This time it's sitting on one of the legs. Now watch. In order to do this, what do? We go from the right angle and we go perpendicular to the opposite side. All right? It's the same thing. It's just tilted. That's all it is. Okay? It's a right triangle. Listen. It's a right triangle with the altitude drawn from the right angle. Everybody see it? Or it's the altitude drawn to the hypotenuse. It's the same thing. Let's put some numbers in here that they do. This is from the example in the book. This time they say this is X. They say this is Y. Oh, they actually make this easy. I thought they're going to make this a little more difficult. And then this is 5, and because I do. All right. Because they used to look like 2s, and so they didn't look like a 2. I put the thing in, and that's kind of a European thing they do. Okay. Yeah. Let's take a look at this. Let's do this really quickly. Okay. Let's solve for X first. Okay. Watch. Let's find X. So X is the altitude, isn't it? Because it's drawn from the right angle perpendicular to the hypotenuse. So that is the altitude. So we set it up. Let's do it very quickly. Put the X here and here. X is a geometric mean between what and what? 5 and 20. That's right. Everybody see that? It's because it's between the two segments of the hypotenuse. If you cross multiply, X squared. Do that in your head. What's 20 times 5? It's 100. Now that's perfect square, isn't it? Comes out even. So if I take the square root of both of these, X is equal to 10. And that's how I want you to write it. Okay? Let's do Y. Let's squeeze Y down here. So Y is the geometric mean as well, isn't it? Remember, these three are geometric means. This is not a geometric mean. This is not a geometric mean. It's just these. The two legs and the altitude are your geometric means. So Y is a geometric mean between what and what? 25, which is the whole entire hypotenuse, right? Just added those two up. And the segment that's closest to the Y, which is 5. All right? So Y squared equals, what's that? 125? And this does simplify, but I'm letting you just keep it the square root of 125. And you can just keep it like that if you like. It's pretty easy, isn't it? Yeah. Let's do Z. We're almost done. Let's do it over here. So Z is also a geometric mean. Just have to know what it's between. Z is a geometric mean between what? The whole thing and the segment that's what? Closest, right? Between these two, that's closest to the Z, which is 20. All right, so Z squared equals, what's that, 500? Is that right? Because 2 times 25 is 50, right? With the 0 on the end. And the square root of 500. Now, if I read answers off, they actually simplify these radicals. Again, it's something you're going to do in Algebra 2. I'm not going to make you in here in geometry. Maybe if we have a day where you have a little bit more time, maybe I'll show you how to do that just to kind of get you rolling on it. So then when you get to Algebra 2, you're like, oh yeah, I remember a little bit of that from geometry. And you should have done a little of that in Algebra 1. Did you guys remember simplifying square roots in Algebra 1? Okay, that's an Algebra 1 topic, but not everybody understands. Okay. All right, let me give you a worksheet, and then I'll hand your test back to you. So the worksheet's front and back, okay? This one is not on, whatchamacallit, digital lockers, okay? I just copied it from the workbook that I have. Maybe next week sometime I'll put Chapter 8 up there. All right, so this is due on Monday.